Okay, good evening. This is Professor David J. De Los Reyes. Okay, the date for today is September 20, 2023. The time is around 11:45 p.m. Is it 11:45? Yeah, it's 11:45 p.m. Okay, my topic for this session will be a long video format discussion, and this will be a topic on college algebra. We are almost done with college algebra. So for those of you who are following my discussion on college algebra, we are almost done. Okay, and the topic for tonight will be lesson number 68. So our lessons are numbered so we know how we progress. Okay, let's proceed. The topic for tonight will be college algebra, and this will now be lesson number 68. We are almost done. Okay, I will try to look for some more topics which are needed in the study of college algebra. Okay, the title of the topic for tonight will be the so-called factor theorem. The last topic, the last time around, it's the so-called remainder theorem. Okay, we now know how to find the remainder of a polynomial if it is to be divided by a binomial. Okay, and to check the validity of that answer, actually, the checking is actually by using the so-called longhand division. So for the remainder theorem, okay, it's an easy one. It is just a direct substitution one to the given function. What remains will just be simply the remainder. That's why it is the so-called remainder theorem. But the good thing about it, we could bring out the remainder by using the longhand solution. Okay. For the topic for tonight is the factor theorem, and the factor theorem is actually different from the remainder theorem. Okay, let's try to bring out the concept of the factor theorem. If we are given a polynomial f of x, okay, and if we are to divide this polynomial by a binomial given the term x minus r, okay, and if we try to place the value r to the given polynomial, okay, we try to substitute it. If what comes out after the simplification is 0, okay, we could conclude, or we can conclude that the factor x minus r is a factor. Okay, it's a factor. Why it's a factor? Because the principle of solving a polynomial is actually to find the roots, right? So on the finding of the solution, if we try to substitute an assumed root, and what comes out is 0, meaning it satisfies the given equation, we could consider that factor to be, that binomial to be a factor. Okay, that's factor theorem. Right? Okay, I will try to repeat it. If we are given a polynomial f of x, polynomial meaning it contains so many terms more than 2, right? And this is to be divided by a binomial x minus r. And if we try to compute for the value r, okay, we put it on the given polynomial. If after simplification what comes out is 0, we can conclude that the binomial x minus r is a factor. Okay? Factor. That's why it is factor theorem. Okay? As simple as that one. Nothing hard about it, right? Okay, let's try to bring out an example. It seems these problems are just for the lower algebra. It should not be college algebra. But it doesn't matter, right? Lower algebra, it goes to higher algebra. Simple problem, it goes to the so-called complicated problem. So it seems this is just a direct substitution, all right? Example number 1. We are given the binomial x plus 3. We are asked to determine if it is a factor of the given polynomial. The given polynomial is actually an expression that contains many terms more than 2, right? So the polynomial f of x, or f of x, will be x cubed minus 4x squared minus 9x plus 36. So the problem is just asking, is this binomial x plus 3 a factor? Okay? And how could we determine if this x plus 3 is a factor of the given polynomial? According to our theorem, if we try to compute for the value of x here, then we try to substitute it on the given function. If what comes out is 0, okay, that's the time that we can conclude that the given binomial is a factor. As simple as that one, okay? So, from the equation x minus r equal to x plus 3, am I still on camera? Okay, I will try to remove my glass, x minus r is equal to x plus 3, okay? R here will be equal to negative 3, right? Because negative r will be equal to plus 3 because this x here cancel with this. Multiplying by both sides by negative 1, r now will be negative 3. Okay? So if we try to follow the factor theorem, according to factor theorem, if we try to substitute this negative 3 here to the values of x, on the given polynomial, if what comes out is 0, okay, we can conclude that the given binomial is a factor. So, function of negative 3, meaning we are to follow this one, and we will replace all values of x by the value negative 3. So, this should be negative 3 to the third power. I'm following this. Minus 4 times negative 3 squared minus 9 times negative 3 plus 36. Okay, I will try to bring out, use my glass. Simplifying this one, negative 3 to the third power is actually 27. The value inside is negative. We multiply it by 3 times. It's an odd number, so the sign of the magnitude will be a negative. So this will be negative 27. Right? We multiply it 3 times, so it should be negative. Negative 3 squared is positive 9 times negative 4 will be negative 36. A negative 9 times a negative 3 will be positive 27. The last part is 36. So luckily this negative 27 cancel with this, and negative 36 cancel with this. So after the simplification, what comes out is 0. Okay? And according to the factor theorem, if after the substitution what comes out, it is 0. Okay? Therefore, we will conclude that, okay, since function of minus 3 is equal to 0, the given binomial x plus 3 is a factor. Right? It's a factor. One of the roots, right? Example number 2. As simple as that one, the factor theorem, right? Determine if the binomial x plus 2 is a factor of the given polynomial function of x equal to minus 2x to the 5th plus 3x to the 4th plus 8x cubed. Okay? Same procedure. Am I still on camera? X minus r should be equal to x plus 2. Solving for r now will be equal to negative 2. This x here cancels, and multiplying this one by negative 1, negative r times negative 1 will be positive r, and positive 2 times negative 1 will be negative 2. So r will be negative 2. Okay? According to the factor theorem, factor theorem, if we try to take this value r, okay, put it on the value of x on the given polynomial, what will be the outcome? So function of negative 2, this should be equal to negative 2. This is negative 2 to the 5th power. I'm following this. Plus 3 times negative 2 to the 4th power. Plus 8 times negative 2 to the 3rd power. Okay? The exponent of this negative 2 is actually odd number, right? So supposed to be, if we try to raise negative 2 to the 5th power, it should be a negative value, right? And that is actually negative 32. Okay? This negative 2 raised to the fourth power, it's an even number. So if we try to raise negative 2 to the fourth power, it should be a positive number. What comes out is positive 68. The next one, negative 2 again to the third power, it's an odd number, right? Odd exponent. So the sign of negative 2 to the third power will be negative. That is actually negative 8. Simplifying this one, negative 2, negative 32, we are multiplying, right? So positive 64. 3 times 8 will be 48. And 8 times negative 8 will be negative 64. So actually, this 64 here cancel with this. And what comes out after the substitution of r equal to negative 2, it is actually positive 48. This positive 48 here is termed to as the remainder. Right? And what's the significance of the remainder? According to the factor theorem, if the remainder is not 0, okay, the given binomial is not a factor of the given polynomial. Therefore, hence, the binomial x plus 2, okay, is not a factor of the given polynomial minus 2x to the fifth plus 3x to the fourth plus nx cubed. Okay, so that will be our answer. It is just a direct substitution problem, right? But at least we now know what is the so-called factor theorem or remainder theorem. Remainder theorem, I will repeat it. If we try to substitute the value r and what comes out is not 0, right? And there should be a remainder, it is not a factor. But under the factor theorem, if we try to substitute the value and what comes out, like in the first example is 0, we could conclude, or we can conclude that the given binomial x plus 3 is a factor. On the second one, since there is a remainder, we can conclude that the binomial x plus 2 is not a factor. As simple as that one. Okay, that's the study of factor theorem. Okay, this is Professor David de los Reyes from Los Angeles. Good evening.